on 380 Lab 7 presentation on relational logic. In this assignment, I built a program that models university admission decision using a knowledge base in data log. The goal is to determine whether student should be accepted based on three pathways. Returning student in good standing with no outstanding fee, student who submit a complete application and are qualified, and legacy students, children of former graduates who submit a complete application. So before diving into the data log program, the assignment asks three preliminary questions. The first question asks us about the basic idea of the top-down proof procedure. So the top-down proof procedure is a goal-directed backward chaining approach where you start with the query and recursively break it down using rules until you reach the facts. The second question is about how you know when you have created a successful derivation using top-down. So a successful derivation is achieved when all goals are reduced to known facts, leaving an empty set of sub-goals or final yes answer. And the last preliminary question is to give an example of an admissible heuristic for top-down search. So an example of an admissible heuristic is the minimum remaining sub-goals. Minimum remaining sub-goal heuristics which selects the subgoal that appear simplest or is most likely to be resolved quickly, ensuring efficiency without overestimating the cost to solve the query. In the data log part of the assignment, I used simple statement to show the rules for accepting students. I had different labels like accepted, returning good, standing, clear balance, app complete, qualified, legacy student, high SAT, good HS, graduate, and child. So, for example, there is a rule that says uh, this one, the first rule. So, this means a student can be accepted if they are returning in good standing and have no unpaid fees. And the another rule uh, means uh, a student can be accepted if they finish their application and meet the qualification. To explain what makes a student qualified, I set up two rules. The one rule says a student is qualified if they are a legacy student. The other rule says a student is qualified if they have high SAT score and good high school grades. So here is my knowledge base. There are facts like app complete, Chris, good high score, Chris. There is a graduate, Sam, and Chris is the child of Sam. Okay. And for Laura, I have facts like she is a returning student with good standing, but I have not been provided with her application completion and her clear balance. So this might affect if she get accepted or not. So now I am going to in this question, they are asking if the Chris will be accepted or not, right? So here is that here's my theory that Chris will be accepted. And in the next question, I have been asked if Laura will be accepted. So I have used AI space for both of them, and these are the answers that you can study my theory. And now I will be showing you how it can be performed in an AI space. So by using the AI space definitive clause detection tool, I simulated a top-down proof procedure for the query accepted Chris. As you can see that the end result is a yes, as my theory suggested. But as I have also told that in my theory that Laura will not be accepted. Let's try that also. As you can see, like there's no path to be searched. That means there was no answer for Laura. So that's all from my side, and thank you for watching this.